It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson.
Welcome everyone to another Pure Performance podcast. And normally the introduction is done by my lovely co-host Brian Wilson, but I don't think Brian is here today. Brian, can you hear me? Probably not, because he's in the mountains today, skiing, enjoying the end of the ski seasons on the West Coast. He lives in Denver, for those people that have not figured that out yet, that are listening to our shows. And he decided to take a couple of days off and enjoy the slopes. But anyway, I think I should be hopefully doing a good show today. And I want to go actually right into the topic, or before going into the topic, actually introducing my guest today. Twan, are you there with me?
Yeah, I'm here. Hi.
Hi. So Twan, the two of us, we met a couple of weeks ago, actually in another ski resort. We met in the French Alps when our friends from Neotys did their Performance Advisory Council, the PAC event, at the top of the mountains in Chamonix. And I believe it was the first time we ever met, right?
Yeah, that was the first time we met. So it's a relatable subject Brian is doing now, because we did some skiing there.
Exactly. Were you, I don't remember, which ski group did you participate in? Was it intermediate, advanced, beginners?
I was in the beginner ones.
Oh, yeah. How did you enjoy your lessons?
Yeah, it was really good. Too bad it was a short ski trip, to say it that way, but I really enjoy it, and hopefully next year they to do the same location, because I really liked it.
Yeah, it was fantastic, and you're right. I think we only had like 2 hours for skiing, because the rest of the time we actually had to talk about performance-relevant topics. And this is also the reason why I brought you on the podcast, because I was really intrigued by your presentation. I think it was called Beyond the Percentage Usage, an in-depth look into monitoring. And I really liked a lot of the concepts you explained, you brought to the table. I think a lot of the folks that sat in the session, it was an eye-opener for many, or for some maybe it's just a reminder, but I think for many it was a great lessons. So Twan, before we go into the topic, and I want you to explain some of the things, can you give us a little background first on your person, on your what you do right now, and why performance is so important to you?
Yeah, I started out working in the IT for 5 years ago, small IT firm, and then I switched to Sogeti, which is my current employer, and started doing performance testing after half a year there. So now for almost 2.5 years doing performance testing, and I think it's the best specialism around, because it's really a really broad skill set you need. So that's why I had a presentation about the in-depth looked into monitoring, but it's also on processes, DevOps, Agile. So I really enjoy that, and currently just working at multiple clients, doing performance tests, but also helping them build DevOps pipelines, all sorts of things.
Yeah. Cool. So maybe we want to talk about this as well, because this is one of the topics I love to talk about a lot, DevOps and how performance fits into the pipeline. But let's start with your presentation, Beyond the Percentage Usage. And I believe you did. We have to give credit to a couple of people here, and especially I think Brandon Gregg, that you referenced quite well to where you got inspired, I guess, for the introduction of use. Right?
Yeah.
Can you explain a little bit what that is all about?
Yeah, so I started doing performance testing, and then of course you need to analyze data, monitoring data, and specifically. So I started looking online, asking colleagues, "Okay, can you give me some reference online or some documentation which I can follow to learn the trick?" Well, there wasn't any, or there isn't much online, so that I stumbled upon the Brandon Gregg site. First, I need to say I stumbled upon a conference from him, which was posted on YouTube. So I watched it, and there he talked about use. So I looked it up online and found his site, and yeah, I was sold the first moment I heard and read about it. I think it helped me a lot analyzing better the results I get from my test, and also I use it to train new performance testers, engineers on how to analyze monitoring data using use, because it's really simple, but in the meantime, it's also, in my opinion, it goes really in depth if you use it the right way.
Mm-hmm. So can you quickly tell us what does use stand for? USE.
Yes, so it stands for utilization, saturation, and errors. The first we all know, it's one of the most looked after metrics. It's utilization of CPU, utilization of memory, maybe even network or I/O. The second one is not that often I see that in reports, but it's saturation. So looking at how overloaded is a system. So how much of the work isn't serviced at the moment, so it's being queued. And lastly, E for errors, it's are there any hardware errors or other errors in the system which may cause performance degradation?
So that means so use is really, and I think this was the interesting moment for me. Instead of looking at a single metric, as you said, like CPU usage, or I think the other example that you brought in, you had many like disk usage. The metric alone doesn't tell you anything, because an 80% CPU utilization can be good or bad, versus also a 10% CPU utilization could also be bad, because you always need to see it in context of the other two. And I believe the example that you brought, now I wrote it down here, you said CPU usage, right? That would be the utilization. Then the saturation can be monitored by looking at things like the run queue or the disk queue when we talk about disk monitoring. And then the error would be something like I think on CPU it's like a run queue latency, or on disk it was I/O latency, or any errors basically that are happening. So I think that was really great for me to be reminded that there's not many metrics where just looking at a single utilization metrics actually makes sense. You always have to look at it in the combination of usage, of saturation, and of errors.
Yeah, of course. That's really, for me, just to say, because for me, 100% utilization, it can be a great thing, because you're now utilizing all those hardware components you have in a server, and maybe you have a cloud solution. You use what you pay for, so that's really good. But then again, if you use 10% of your CPU and you maybe look at a saturation metric, for instance, run queue, and you see it's really high, that means there's a serious problem, because the CPU isn't doing anything, but all the instructions to the CPU are being queued. So there's a bottleneck somewhere in the system. And you wouldn't have noticed it if you were only looking at CPU utilizations. And the same goes for disks or network or memory. So what you were saying, it's true. It's the combination of all those types of metrics, so utilization, saturation, and errors, which give the big picture, which you need to find out. So purely looking at one metric isn't enough.
Mm-hmm. And now in your work, you said you're working with a lot of clients on individual projects. So that means you are obviously faced with all different types. I would assume with every engagement, you have a different environment you're testing against. So with different environment, I don't just mean the application, but a different stack. I would assume so, right? It's very different every time.
Yeah, it's really different. It varies from cloud solutions to on-premises hardware to private cloud solutions, which range from AIX machines from IBM to the newest Intel machine. So every client has a different stack. But then again, if you use, it's a bit of a tongue breaker, but you can apply it on any stack, on any OS, on any metric.
No, and I was just wondering then. Yeah, you get that was kind of the point that I wanted to make. So you can apply it, but do you always get all these metrics? I mean, are for let's say for CPU, for memory, for disk, and for network, does every stack, every OS, every cloud vendor, do they give you these metrics? Are they available, or how do you deal with that?
Oh, yeah. It also depends on the stack, but for let's say for most on-premises solutions, you have the metrics. Some of the times errors is a bit hard because you're mostly looking for hardware errors, and those mostly aren't passed through to, let's say, a VM or because that it's handled at the infrastructure department. For cloud solutions, it's really hard because you have no idea how busy the host is, how big the pipe from the host to the VM is. So you do your best with the metrics you have, but then again, it still gives a good picture if you look at saturation, because if you see a big process queue being built up, you know there's something maybe happening on the host part. So you can contact your cloud provider and say, hey, I see a lot of queuing. The CPU isn't doing anything. There's no memory bottleneck or IO bottleneck. What's happening? Can you tell me? So it also gives you some handles to maybe challenge your cloud provider.
And so that's a good point. So that means you can actually go back to the infrastructure team, and whether this is the your own team because you run on premises, or whether it's the cloud vendor. Now, I assume you've done this in the past, and are they receptive? Like, can you go to an Amazon or to a Google or Microsoft and say, hey, I see very strange behavior here, and I assume it is the underlying hardware. Can you look into this? Are they willing to do this, or what is their typical answer?
For me, it was always no. So maybe the clients were too small at Amazon, but they're not willing to give up any information. This is the same if you look at. It's a bit of a side note, but if you look at CPUs, and now the new generations, they have turbo frequencies.
Mm-hmm.
That can impact a lot on performance, but they won't say which chips they're using, so you have no idea if you have any issues on the platform itself. So that's really hard. Opening up those metrics on let's say Azure or AWS.
Yeah. Even though maybe this is a shout out that we can do to these cloud vendors to open up these metrics, because if they do, we can better utilize their resources. And I think if one starts to do it, it could be a nice competitive advantage versus the other. And then hopefully the others will catch up and say, well, we are giving you all the metrics that you need, so you can make better decisions and you can better optimize the code that runs on our infrastructure. I think so. It maybe a little shout out to the cloud vendors of the world out there.
Yeah, that would be great if we have more metrics. It's again, more information can lead to better analysis and in the end better code, better decision making on architectures. So it will help a lot if they open up. So Google, if you're listening.
Exactly. Google, Amazon, and Microsoft, if you're listening, give us these metrics, and also listen to if people ask you like Twan, and even though some of these projects might be small, you should still not just give a no as an answer. That would always be good. The other thing that I remember from the presentation, you talked about eBPF and BCC. Do you know what I'm talking about? And
yeah, of
can
course.
you give us a little insight?
Yeah, so you just talked about a saturation metric for CPU. Let's say a run queue. Then a run queue is a number for how many items are in a queue for the CPU, but it's hard to give a real value to this metric. And then comes eBPF. It's based on some really cool features in the virtual the Linux virtual machine, which allows you to get your hands on new metrics, which they were available before, but were really hard to measure. For instance, you can measure the schedule latency, so it's possible to have the metric on how big is your how big is the queue, but also what of an impact has a queue of, let's say, 10 items. You can now measure with eBPF and BCC how much milliseconds this queue was. So this is really helpful, because now you can say, okay, I have a queue of 10, but it doesn't give a big latency because it's in nanoseconds. But you can also measure schedule latency of, let's say, 45 seconds. Now I have a big problem. So because the CPU instructions are waiting for 45 seconds before they even are processed on the CPU. So it opens up a really cool new pool of metrics, which can be used, and also in combination with use, it gives a good picture on how the system is performing.
Very cool, very cool. Hey, come in. So we will also put some links into the description of the podcast. So we talked about eBPF and BCC, and in the beginning we talked about the use method that was made popular from Brandon Gregg, and the website is Brandon Gregg with 2 G's at the end.com, and there's a lot of useful information there. Now, Twan, I have another question coming actually back to a scenario when you use, as you say, it's a little tongue breaker, but if you use with your projects and you figure out, hey, there's something wrong with CPU or disk or memory, and what are, one potential root cause could obviously be the underlying hardware, but have you seen cases where it was actually not the underlying hardware, but it was actually maybe the stuff that ran on these machines, maybe too many processes or bad coding, bad applications? Are there problem patterns that you have seen that were causing, let's say, a low CPU but a large run queue? Is this something like this that can also be impacted by applications? Have you seen this before?
Yes, it's lots of. I have many examples, but one of the things I saw was there was a really low CPU utilization, but the system really hangs. So long response times during the performance test. So then for me, I use, and then I go down all these metrics. So I started at utilization and see low utilization, and I came to the saturation. So I pulled the run queue metric, and I saw a really big queue. And then I was like, okay, what is happening? So I started to pick another group of metrics. So I go to I/O, and there are also a big queue. So for me, then I know, okay, maybe the run queue on the CPU is caused by slow disk. So I was looking at the amount of reads writes to the disk that weren't that high. So then I used a tool in the BCC collection, which shows all the reads and writes to the file system, and also in particular which files are being read or write or read during the test. So then I saw a config file being like hammered every time a request came in. So I asked to the developer, okay, what are you doing with this config file? And he said, yeah, every time there is a request, we pick the latest config and we make the connection to the database. So then putting all those pieces together, it was very clear to me that each time I send a request to the server, the specific config file was being picked up by the application, and that caused a lot of I/O latency, because we were hitting it with like 2,000 to 3,000 requests each second. So the file system couldn't keep up. And the only way for me to really get that information really quick was by using BCC tooling. And it was in a matter of minutes I had that metric up, and I saw the huge amounts of reads and writes to that particular file, and it was a quick solution after that. But it really helped me in a case where the application was the problem during an analysis.
Mm-hmm. And I think it's a problem that I've seen in the past, where whether it is on purpose done by the developers or if it is done by the frameworks that they're using. Right? Typically, as I think you mentioned that they were making database connections. Very often, these things are completely hidden away because you're using frameworks that are abstracting the data access layer from you. But then these frameworks are obviously internally, checking the config files. And then typically there are settings where you can say, well, check the config file with every access or cache it and then only refresh it every minute or something like that. And it seems in your case you had the scenario where every single request was rereading that config file, and that obviously with increasing load puts load on disk on I/O. Things are queuing up, and then you'll never be able to utilize the CPU. And obviously, in the end, you will see huge response times on a system that seems completely underutilized from a CPU perspective because you're completely slowed down because of a disk queue problem. Besides CPU, disk, memory, and network, do you have other examples on how to use? Any other examples?
Yeah, usually you do it for hardware metrics, but lately I started using it also for using to do performance metrics. So how many hits per second a system can handle, or how many how big the response time is then. But then again, use is it is general. You can also apply it to let's say a factory. If you use utilization, you can check how many workers are busy doing the work. But if you have too many factory workers on a machine and the machine is clogged up, you are still saturated, but not at utilization part because all those workers are standing still.
And especially maybe the first example that you mentioned, we in the performance world, when we are testing, let's say, microservices or any type of component that is handling the requests that we are executing from a load testing tool. So we would obviously measure throughput as a way, but then also, as you said, queue length on, let's say, an application server or on a web server. So how many requests are actually queuing up, and then the failure rate, right? I think that's also another thing. You can do this on an application level by looking at the HTTP responses. So you can figure out, okay, so what's the throughput? Do we see things queuing up on the application server, and what's the failure rate? What's the HTTP status codes that are coming back? And I think with this, you often probably find out that the system is currently pounded with too many requests. Now they start also failing, and things are queuing up. And I think these are classical metrics that I would look at on an application server or even web server. I also like the example that you brought with the workers, but it comes back to the same thing. As you said, you can apply use to pretty much everything, and I think that's the thing that I wanted to make sure that our listeners also understand that. If you have a single metric, try to figure out what other metrics on the use pattern, so utilization, saturation, and error, you can pull in to get a better picture, because a single metric doesn't always give you the full story. I think that's what it is, right?
Yeah, that's really the message to bring across when using use. It's the same. Every component, every line of code, every piece of middleware, it all together makes the application. So it's the same for metrics. You can't do analysis based on like 4 metrics. You need the whole picture to get to see what's really happening on a system. Mm-hmm. So that, yeah, and using a methodology like use helps you to get these metrics. But because if you go just look at different graphs, you're not doing it consistently, but also you're running ahead like a headless chicken, just plowing away through data.
Mm-hmm. Yeah. One thing that we started doing at Dynatrace is when we detect, let's say, a slowdown of a front-end service that you are, for instance, testing, then what we are doing, we're actually walking through the whole dependency tree. So we're looking at every metric that, from that service that you're testing, from the underlying process, from the underlying host, but then also all the dependent services and the dependent processes. And then we look for anomalies. But we do this on every single metric. So we figure out which metric is behaving abnormally as compared with the time before the problem happened. I believe what we should start thinking of is then clustering these metrics, the 3 metrics, into a use metric. Or really, I need to talk with our team if we are already doing this or if we should do it, because then you can make immediately better recommendations to the people that look at our monitoring data and say, hey, we see that the CPU is abnormally low, but it doesn't mean that you're underutilizing it. The problem is that you have a very high queue length, and these two are obviously correlated, and therefore you should look into what is consuming all of these. Why are things queuing up? So I think that's something I want to propose to our team.
Yeah, it's really cool because most Dynatrace is known for building clients building great dashboards, and they always have CPU utilization. And if you have maybe you have some alerts being you have a setting which may alert you when the CPU is really high, but you don't have most of the time have an alert when the CPU is really low. But when the CPU is really low, you can have big problems on other parts of the system. So what you're saying is really cool, like combining metrics into one use metric and measuring that. And if there's an anomaly on any part of the use metric, you can alert the right guys and give them the right feedback they need to address problems.
Yeah, exactly. Cool. Hey, Twan, is there anything else? Looking back at your presentation, is there anything else we should cover?
We have the really cool stuff we talked about: use, eBPF, PCC. Again, one of the things I also wanted to give across with my presentation is start digging into metrics and start learning more about how do these components work and how are they related to each other, because I find it really fun, but also I think many performance testers and engineers aren't doing it that much. They're more keen on building tests rather than digging deep in the metrics, but I find we need to do it more.
Mm-hmm.
So
yeah, and especially, as you said, there is I think this also differentiates you from a regular performance engineer, or let's say this differentiates people from being a performance tester and a performance engineer, because a performance engineer understands how the individual components that make up the application or service that they're testing, how they interact with each other, how they're impacting each other. And from a component perspective, as you say, we could talk about the service, we could talk about the process, we could talk about internals of a runtime. A classical example that just comes to mind is what's the impact of high garbage collection to CPU or high memory churn rates to the garbage collection, and then if you have high garbage collection, how does that impact CPU? So there's a lot of things that are connected, obviously, and you're completely right. If you're just creating tests and then just say, hey, something is slower and here's the reports, then whoever needs to look at the reports needs to do all the heavy lifting, and I think this is not what we should do. I think we should think about how can we provide better analytics on top of all the data that we have, so that the people that need to look into this can much faster figure out what is the root cause and then address the root cause. And with this, I think we're moving towards we're moving from performance testing to really performance engineering, and to something that I would love to call performance engineering as a service, where eventually, Twan, right, you also want to automate as much as possible your work right now of digging through all the metrics, and then maybe just give the developers or architects at the end of your test a link where maybe you build some analytics engine that automatically analyzed all the metrics based on your approaches, and then they can just consume that data. And whether it's something that you build, whether you're using tools that can do this for you, whether it's Dynatrace or Neotys or any other tools, I think this is where we need to go to. And in order to get there, we need to better understand the relationships between the metrics, how systems actually are architectured, how they're talking with each other, how they can influence each other. And I think this is separating the regular performance testers to the performance engineers.
Yeah, I think that's really true, because most of the time I'm now at a client, I'm not even performance testing anymore. I'm just building an infrastructure to what you were saying, how a fully automated pipeline, and analyzing data is a big part of it. You need to know, really need to know on which metrics you can measure and how you need to measure them. So applying use is, for my instance, is really good, because when you are automating your analysis, you need to make sure, you really make sure you do the right thing.
Mm-hmm.
And if you use Dynatrace or any other tool, then again, you need to know how to apply a good APM tool, because if you don't, it isn't being used to its full potential, and that's really a loss of money, and even can be dangerous when you solely rely on one metric for your performance test or your pipeline.
Yeah, I think this could be the title of a blog post. How to be dangerous. It's dangerous to only look at a single metric. Yeah.
Yeah.
Don't get fooled by response time as your sole metric, or don't get fooled by CPU utilization. Yeah, that's a cool one. Hey, let's quickly, before we stop, talk about DevOps and pipelines, because this is a topic that is dear to my heart, on how we can integrate monitoring data in the delivery pipelines. So you said when you go into customers right now, you're often building automation and pipelines. Can you tell me a little bit more about how that looks like, what you really do there?
Yeah, so currently I'm building their future architecture. They want to know how can we be more agile, and how can we move to DevOps. For performance testing, most customers or most clients in the Netherlands, they are still a bit behind, so they still use those centralized teams who do the performance testing. But that's not a viable option when you're going DevOps or even applying Scrum. So then you need to automate the performance test, but also automate a big part of the analysis, because if you have like 50 Scrum teams, you can't have 50 people analyzing every pipeline run, because that's crazy. So what I do at this client, I'm building a fully containerized platform where the test is automated by a Git a commit on let's say GitHub. Then everything is pinned up. So I use Neoload in Docker to start the infrastructure. Then I do a test, and then the plan is to pull the monitoring data from an APM tool, or push the performance data to the APM tool and use that to do a quick analysis on certain metrics we find important for that specific client, and then give a status back to Jenkins to either hold or discard the pipeline or the build. So that's and the tricky part is how are you going to automate the analysis? I'm really struggling, or not struggling. I'm really finding out really new things every day. So that's really cool.
Very cool. And and this is a trend that I've seen, and I think this is where what I mentioned earlier with performance is a self-service, because what you're building allows everyone to simply make a code change, and then minutes later, hopefully, the automated Jenkins pipeline or whatever CI tool you're using will test your code or deploy and test your code and give you feedback on key metrics. And I think the biggest thing here is, has something changed to the previous build? Do we have a performance or what I also always call an architectural regression to the previous code change? Like, do we make 50% more times access to that config file, right? That could be an interesting metric. Maybe somebody forgot, yeah, and it doesn't always have to be a response time or memory consumption, but just the way your services and applications are interacting with the other services and resources around them. And having this fully automated really allows you to then scale this, because as you said, centralized center of excellence teams cannot cope with this anymore, and therefore you need to automate as much as possible.
Yeah, and the first thing you see is it's they integrate the test in a pipeline, and that's really good because that enables you to run tests without any ever touching a server or pressing play. But then you still need to analyze the results. And that's mostly a big chunk of the work when you do a performance test. So automating these steps, they really need to be done if you want to go have a good DevOps environment. So I'm still looking for good examples on. I know you did a great. Was it on Perform? You and Hendrik gave a demo about this.
Yeah.
So
yeah, no, it was really cool. Yeah, we did some work on how we can integrate Neoload with Jenkins and with Dynatrace to fully automatically execute tests that are triggered by a code change and then pull back data into Jenkins. So just the same thing that you just explained. And what we're also doing now, and maybe a little plug here to some upcoming podcasts, that we have an open source framework now that is called Captain, that we're building. So it's open source, and what it really does, it tries to automate all the plumbing between your CI, so your build, your deploy, your testing, and also your validation. So if you want to have a look at it, captain.sh, and Captain is spelled KEPTN.sh. That's the website. And the idea here is we want to make sure that people who are building microservices, that they don't need to worry about building large pipelines anymore, that are doing the build, the deploy, the test, the validate, and then deploy it into the next stage. This is something we can also automate. And so Captain, the framework, is really all about automating quality gates, and also on the production side, because it doesn't stop there. In the production side, it automatically supports deployment models like blue, green, or canaries, and then also supports things like auto remediation, and and also Henrik from Neoload, he's also a crucial part to that project because he's contributing extensions from the open source project Captain to their tools. So it's all good stuff.
Yeah. So and when you're saying it's also auto remedy, it's a cool new feature which is popping up more and more. And then again, the same applies for those rule sets which are being used for auto remedy. When are you going to do certain steps? So also looking in the right metrics to trigger a remedy.
Yeah, exactly. And then the use metrics can obviously come into help, because if you see response time going up and you see still like low CPU, then what do you do? But if you then look at the other metrics, you see, oh my God, there's something going on here, the queue length. Oh, now I know where I need to, what my problem is, and this is what I need to address.
Yeah. It's there are examples when you spin up a new node which only increases the problem. So it's maybe better to sometimes decrease certain parts of the application to dam in the amount of calls coming into a server. So it's then again, using the right metrics. It's key to also automate your pipelines or not your pipelines, your performance tests, but also in production.
Yeah. Cool. Hey, Twan, I think we want to wrap it up here. Thank you so much for being on the call. I typically do a quick summary at the end. Brian, who hopefully is still on the slopes and enjoying the snow in the Rockies, he's typically then saying, shall we summon the summarator? And that's what I'm doing right now. I summon myself. So I think what I've learned is that every seasoned performance engineer differentiates itself from a regular performance tester by understanding all the metrics that they need to look at, how the metrics interact with each other, and therefore you really set yourself apart from the classical performance testing we used to do and what performance engineering has to be. And the next step will be to automate a lot of the analysis, bake it into pipelines so that large teams, large organizations with many, many development and Scrum teams can also leverage it, fully automated like you do with the work you're doing right now with this customer where you build the DevOps pipelines. There's more information to be found on use. So use stands for usage, saturation, and error online. So you can check out the work from Brendan Gregg. He is the guy who inspired also Twan here to look into use and check it out. Also check out the link to Twan's presentation at Neotys PAC. A big shout out also to Neotys for constantly and repetitively, getting us together as the Performance Advisory Council. Now I also know that they are hosting Whopper this year. So in case people, I think it's going to be in Marseille in the end of May. And it's another great workshop around performance engineering. And I think they still have their call for papers open. So Whopper, WOPR, check it out in case you want to go to the south of France in May. All right, Twan, any final words on your end?
I'd really like to thank Neotys for having me at PAC. It introduced me to you, Andreas, and we have this talk today. I really enjoyed it, and again, to everybody who's listening, just start digging up more metrics. I won't spoil my presentation if you haven't seen it, but I have a cool Star Wars reference based on monitoring.
Yeah, exactly. Cool. All right. Well then, Twan, hope to see you soon in person. And if there's anything new coming up, any new lessons learned, just reach out to us and we'll get you on air again.